Welcome to The Explainer. Today, we're going to talk about how to go beyond just tinkering with AI tools and really start designing lesson plans that harness their true power in the classroom. This is all about making AI work for you and your students intentionally and effectively.
All right, so here's our game plan. We're going to walk through 5 crucial stages, almost like following a teacher's journey. We'll start with the big picture frameworks, then get into planning with a clear goal, then we'll craft the actual AI activities, see how AI can transform assessment, and finally wrap up with how we can reflect and make our lessons even better next time.
First things first, we need a blueprint. Before we start building anything with AI, we've got to understand the fundamental models that help us think about where technology fits into our teaching. So we've got 2 really important models here. Think of TPACK as your foundation. It's about the knowledge you bring to the table, that sweet spot where your tech skills, your teaching strategies, and your subject expertise all overlap. Then you've got SAMR, which is more like a ladder. It helps you ask, how deep am I going with this tech? Are you just swapping out a worksheet for a PDF, or are you doing something that was literally impossible before?
Let's look at a classic example with a teacher named Sophia. She gets this cool adaptive AI math tutor. So she's got the technology and the content down, but her students, they're just getting frustrated. So what went wrong? Well, that crucial third piece of the TPACK puzzle was missing: pedagogy. She hadn't actually planned how to teach her students to use the tool effectively or how to make sense of its feedback.
Sophia's story is the perfect lead-in to our second stage, the plan. Because honestly, the single biggest mistake we can make is starting with a cool, shiny new AI tool instead of our actual learning goal.
And this is where backward design is an absolute game changer. It's a simple, powerful 3-step process. Step 1, start with the end in mind. What do you actually want your students to be able to do? Step 2, figure out your evidence. How will you know they got there? What does mastery look like? And then, and only then, do you get to step 3, planning the activities and picking the right AI tool that helps students get to that goal.
And get this, the data backs this up in a big way. Research from McTeague and Thomas found that when teachers use this approach, their activities and assessments are a whopping 22% more aligned. That's huge. It means everything in the lesson is pulling in the same direction, which, as you can imagine, leads to much deeper learning.
Now, let's look at Anna. She wanted her students to develop critical thinking skills by analyzing poetry. Awesome goal. But she started with the tool, an AI chatbot. And what happened? Her students just ended up copying what the AI said. The activity she designed didn't actually lead to the skills she wanted to teach. See the pattern? The tech came before the pedagogy.
Okay, so how do we avoid these traps and build genuinely great AI activities? Well, it all comes down to how we talk to the AI. There's a name for this skill. It's called prompt engineering, and frankly, it's becoming a must-have for teachers.
Think of it like this. If you give the AI a lazy, vague prompt, you're going to get a lazy, generic answer. It basically becomes a boring search engine. But if you engineer a really good prompt, you can turn that AI into an incredible co-teacher. You're not just asking a question, you're giving it a clear role and instructions to support your lesson. A really great educational prompt has 3 key ingredients. First, give the AI a role, a persona. Tell it who to be. Second, give it a really clear and specific task. And third, tell it what a good answer looks like. Give it success criteria. This structure is what makes all the difference.
I mean, just look at the night and day difference here. The initial prompt, describe World War I, is going to get you a boring Wikipedia summary. But the revised prompt? Wow, you're asking the AI to be an eyewitness to describe a specific event from that perspective and to include things like emotion and uncertainty. The output goes from being a dull report to a rich, creative, and analytical source that students can really sink their teeth into.
Okay, so we've got this great activity, but how do we know if students are actually learning from it, in the moment? That brings us to the feedback loop and using AI for assessment.
The goal here is to shift to what's called formative assessment. It's feedback for learning, not just feedback of learning. Famous research by Black and Williams showed this is one of the single most powerful things we can do to improve student achievement. And now AI lets us provide that kind of supportive, real-time feedback at a scale that was just impossible before.
And the results are pretty stunning. A landmark study by Van Lin found that AI tutors providing this kind of adaptive, real-time feedback have a massive impact. To put that number in perspective, an effect size of 0.76 is considered huge in education research. We're talking about a major tangible improvement in student skills.
This all comes back to a big idea from the psychologist Vygotsky, the zone of proximal development. What AI allows us to do is something called dynamic assessment, but for every single student at once. It can figure out exactly where a student is and give them that perfect little nudge, that just-in-time support they need to take the next step.
And that brings us to our final and maybe the most important stage. Our job isn't over when the lesson ends. We absolutely need a process to reflect, look at the data our AI tools are giving us, and continuously improve.
Kolb's experiential learning cycle is a fantastic framework for this. It's a four-step loop. First, you have the experience. You teach the lesson. Then, you reflect on what happened, what you saw, what the data says. Third, you try to figure out why it happened that way. And finally, you plan your next experiment. What are you going to tweak for next time?
And if you want to make even faster, smaller tweaks, the Plan, Do, Study, Act cycle is another great tool. It lets you quickly test a small change, study the immediate results, and then act on it, maybe for the very next class. It's all about being nimble. And believe me, this iterative work pays off. The evidence is just crystal clear. Studies show that teachers who systematically use data to refine their AI-enhanced lessons see real gains in test scores. But even more importantly, look at that second bar. This process actually helps close attainment gaps, which is a massive step towards more equity in our classrooms.
Which brings us to a final, pretty deep question to leave you with. In this new world, with students, teachers, and AI all working together, when the lesson's over and you're looking at all that data, who is really doing the most learning? The student? The AI? Or could it be that with these new tools and frameworks, the biggest learning opportunity of all is actually for us, the educators?